In this video, my main target is to discuss about how the moment of resistance of a doubly reinforced section is happening or how it behaves. Before that, I will explain the thing which I have explained in my previous video. This is about how to calculate the required reinforcement for the compression and how we can calculate the moment of resistance. Here, here these are the details. This is a rectangular section with 150 millimeter width and the depth is 350 millimeters and the effective depth is 300 millimeters. Depth is 350 while the effective depth is 300. So we can take, or we take that the compressive strength of the concrete is 25 and the strength of the steel is as 460 Newton per square millimeters. Here, as we know the reinforcement in the bottom, there are two T25 bars. So the area we provided for the steel is 981. That comes with that simple calculation. Two into 5i squared. Here r is 12.5. By using that, we can get this answer. As here d dash is the effective depth of the compressive steel, as that one is 50, that one is 50 millimeters. The ratio between the depth to neutral axis to the this 50 is 0.33, as that one is lower than the 0.43 according to the BS 8110. That compression is still also at the yield state. So as the tensile strength or the tensile forces and the compression forces inside this section is equal, to balance, to make the equilibrium, we can use this equation, as this one is the tensile force by the bottom reinforcement and this one is the compression force of the top reinforcement, and the remaining compression force will be occurred in the concrete. By solving or by subjecting this A dash, that is the area of the compression steel, we can take it as 412 square millimeters. Okay, here my main target is to discuss about how these composite means reinforcement, compression reinforcement, tensile reinforcement and the concrete, behave to maintain the moment of resistance of this section. Here, as there are two sections, or as there are two parts which are responsible for the compression, those are concrete and the reinforcement. This is, by this line we denote the compression reinforcement, while this one is concrete section, concrete compression section. By using these two parts, the compression will be carried out, while this tensile reinforcement will be divided into two parts. It's just like that tensile reinforcement divide its responsibility to bear this reinforcement part and the concrete part. As this reinforcement part, here the compression reinforcement is 412 square millimeters. There should be, not there should be, it must be 412 millimeter of the tensile reinforcement should be there to bear this compression reinforcement. After that, 570 square millimeters remain for the remain to bear the concrete compression, and by these two sections, it means this 412 and 570, both of parts carried out the compression separately, and finally the tensile force and the compression is equal. Compression force equal to tensile. Then as we calculated here, we can take the compression force. And as we know that the distance between these two reinforcement is 250, because this whole depth is 300 and the distance from the top to this compression reinforcement is 50. Then the distance between these two reinforcement bars is 250 millimeters, and we can find this z. Z means the distance between the tensile reinforcement to the center of the concrete section. We can find it d minus 0.5 0.45 into d into 2. That is d minus 0.45 into d over 2, that is 232.5, as d is equal to 300. Then we can find the bending moments, or the moment of resistance of each part. Let's take this one as 1 and this one as 2. The moment of resistance by tensile reinforcement and compression concrete is equal to, here we use the length of the lever arm, and this one is, fy a is 2. Here a is 2 is equal to 412 into 250. Okay, this is the thing which I wanted to explain. Here a is 1. A is 1 means the value of this 570. By solving this equation, we can take the moment of resistance of this section. That one is equal to 0.87 into 460 into 570 into 230 232.5. That is the lever arm. Here 250. It is the distance between two top and bottom reinforced bars. This answer is equals to 94187.06 Newton millimeter. Here, this is the thing which I wanted to explain, because some of us will worried about how this came. Thank you.